So today we're going to look at infinite limits and limits at infinity and what the difference is between both of them. So just for, if you're keeping score here, 1.5 is where they talk about infinite limits. And they don't talk about limits at infinity until 3.5, but I figured it would be worthwhile to put it here. So we're really doing two sections. They're both pretty easy and a lot of review. So first of all, an infinite limit is the result of a limit. So if you take the limit as x approaches a number and you get a very, very high number or very, very low number, that's an infinite limit. So and that's actually the definition of a vertical asymptote. So that's what you're seeing here. So it says if f of x approaches infinity or negative infinity, remember f of x is the value, as x approaches c from the right or the left, so it doesn't matter, it could be one-sided, then by definition, that line x equals c is a vertical asymptote. Now, the next theorem that follows it is just the theorem that shows how you can find some vertical asymptotes. And this is what we've been talking about all semester so far, really. If you have a fraction, that function would have a vertical asymptote at the value of c that the bottom goes to 0 and the top does not go to 0. So again, that's something we've been talking about a lot. So here's some examples. First one is determine where this function has a vertical asymptote. So what you want to do is figure out where the bottom is 0. So since the bottom is x squared minus 9, and x squared minus 9 equals 0 when x is plus or minus the square root of 9 or plus or minus 3. That's the two vertical asymptotes. Make sure neither of those numbers make the top go to 0, but they don't. So those are the two vertical asymptotes. There we use the theorem. The next question, you should try this on a calculator. So it's just asking what the limit is of the graph of the natural log of x minus 1 as x approaches 1 from the right. Now, we haven't learned any good way to do this analytically, so I'm going to do it numerically. To do so, I'm going to graph y equals the natural log of x minus 1. And then since we're approaching 1 from the right, I'm going to look at the value, say, at 1.00. And that gave me negative 6.9. So that doesn't seem like a big number. I'm going to get closer. Let's try 1.000001. Now it's negative 18. So it's still not a huge negative number, but it is getting larger. Get closer. Missed again. Okay, so 1.000000. That's very close to 1 on the right. And now it doesn't even come up with an answer. So you can see what's going on. The limit is going is actually decreasing without bound. I'll do one like this, if it gives me an answer. Now, I think because it's so far off the screen, but it will be going to negative infinity. So that just shows you the thing that tells us about the function is by definition, by this definition, since the function is approaching negative infinity as x approaches 1, then by definition we can say that this graph has a vertical asymptote at x equals 1. So the top function we found vertical asymptotes just by the theorem. Bottom we found the vertical asymptotes based off the definition of what a vertical asymptote is. Now, if you remember properties of limits, these are a little bit different because this is saying if we have a limit of a function and it is going to infinity, and then another function that has a limit as x approaches c, here's what happens when you combine them. If you take the limit of a sum of both of these together, you will get infinity. You can think of it as infinity plus a number is still infinity. Product, same thing. Now, if it's also telling you watch the signs. So your limit's going to infinity, you're multiplying it by a positive number, then it will go to positive. If you are going to, if this L is negative, then negative times infinity will be a negative infinity. And finally, if you had a limit and G, the limit of G is just a single number, the limit of F is infinity, if you divide those, it will be 0. And you want to think of that this way. Say G had a limit of 7, F had a limit of infinity. Well, any number divided by infinity is more or less just going to go to 0. Similar properties for one-side limits when F is approaching negative infinity. So here's just a couple of examples of that. If you, first one, number 1, the limit as x approaches 0 of 4 is 4. And the limit as x approaches 0 of 1 over x cubed is either plus or minus infinity because it has an asymptote. So this overall limit. The next one. Now we bring trig into the mix. So the tangent of pi x, if you plug 1/2, we'll be taking the tangent of pi over 2. Pi over 2 is right here, and tangent is sine over cosine. So since this point is 0, 1, tangent will be 1 over 0, which would be a division by 0, which constitutes a vertical asymptote. Therefore, since we know tangent is going to a vertical asymptote there, it's going to be infinity. When you plug in the 1/2 to the top, you'll get 1/2 cubed plus 2, which is 1/8 plus 2, which is just a number. And this very small number divided by infinity is 0. So that's an example of what we were talking about here. Finally, this limit. When you plug in 2, you'll get 2 to the 4th, which is 16, the first limit, and then plus 2 will make the bottom 0, not the top. So this is going to be plus or minus infinity. If you look at it, the graph coming from the left, it's going to be in that it's going to be negative infinity. So this would just turn out to be negative infinity. So that's how you're going to use properties to evaluate limits when one of them goes to infinity. Stop this now, and then we'll come back with the next video starting with these graphs.